Today's lesson is on angles of elevation and depression. Take a minute to read over the learning goal and scale. Find where you are on the scale before we begin the lesson. Suppose you are standing on the ground and you look up to see a hang glider. The angle at which you look up above your horizontal line of sight is the angle of elevation. If the person in the hang glider looks down and sees you, the angle at which he looks down below his horizontal line of sight is the angle of depression. We can use the angles of elevation and depression as the acute angles of right triangles formed by a horizontal distance and a vertical height. In example 1, we will identify angles of elevation and depression. What is the description of the angle as it relates to the situation shown? For part A, we are looking at angle 1. Since the horizontal line that forms angle 1 is the bird's line of sight, and the other side that forms angle 1 goes down to the man, angle 1 is an angle of depression from the bird to the man. For part B, we will look at angle 4. Since the horizontal line that forms angle 4 is the line of sight per se of the base of the mountain, and the other side looks up to the man, the angle 4 is the angle of elevation from the base of the mountain to the man in the balloon. Pause the video and do you try number 1. What is the description of the angle as it relates to the situation shown? For part A, we are going to look at angle 2. Since the horizontal line that forms angle 2 is the man's line of sight, and the other side of angle 2 looks up to see the bird, angle 2 is an angle of elevation from the man in the balloon to the bird. For part B, we are going to look at angle 3. Since the horizontal side of angle 3 is the man's line of sight, and the other side is looking down to the mountain, angle 3 is an angle of depression from the man in the balloon to the base of the mountain. In example 2, we will use the angle of elevation. Suppose you stand 53 feet from a wind turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground? We know that the height of the turbine will be x feet plus 5.5 feet. We have a right triangle with a given angle of 56.5 degrees. We are looking for this opposite side, x, and we are given the adjacent side of 53. Since we are looking for the height of the opposite side and we know the length of the adjacent side, let's use tangent of 56.5 degrees. To get x alone, we will multiply tangent of 56.5 times 53. Using your calculator, type 56.5, hit the tangent button, times 53, then the equals button. X is approximately 80.07426,526, which is very close to 80 feet. Since x is the height of the wind turbine above the man's line of sight, we still need to add his height, 5.5 feet, to the 80 feet to get the total height of the wind turbine. So the wind turbine is approximately 80 feet plus 5.5 feet, or 85.5 feet. Pause the video and do you try number 2. You sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground. You are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? Let's start by drawing a picture to illustrate our word problem. Our angle of elevation is 32 degrees. We are 1,000 feet from the base of the cliff, and we are 6 feet above the ground. We are looking for the total height above the ground of the rock climber, so we must add the length of the opposite side of our 32-degree angle to 6 feet. Since we are looking for the length of the side opposite our 32-degree angle, and we know the length of our side that is adjacent, let's use tangent of 32 degrees. To get x alone, we will multiply tangent 32 times 1000. Now use a calculator. Type 32 and hit the tangent button, times 1000, and hit the equal button. X is approximately 624.8693519 feet, which is approximately 625 feet. Since the rock climber's height here is 625 plus the 6 feet above our line of sight, we must add x, or 625, plus 6 to get the total height of the rock climber from the ground. The rock climber is approximately 630 feet above the ground. 631 feet. In example 3, we will use the angle of depression. To approach runway 17 at Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from a height of 2,714 feet above sea level. The airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airport at the start of this approach? The airport is 1,007 feet above sea level. The airplane is 2,714 feet above sea level. We know the height of the airplane above the height of the airport is going to be 2,714 minus 1,007. 1,707 feet. Since the ground and the plane's line of sight are parallel lines, our alternate interior angles are going to be congruent. So this angle will also be 3 degrees. If we want to find the distance from the airplane to the runway, we are looking for the length of the hypotenuse of our right triangle. Since we know the length of the side opposite our 3-degree angle, and we're looking for the length of the hypotenuse, we will want to use sine of 3 degrees since sine equals opposite over hypotenuse. Since x is in the denominator, x and the angle will switch places and will divide. On your calculator, type in 1,707 divided by 3 and hit the sine key, then hit the equal button. X is approximately 32,616 feet. Since the question asks how far the runway is from the airplane to the nearest tenth of a mile, and we know that there are 5,280 feet in a mile, we will divide 32,616.19969 by 5,280, and the airport is approximately 6.2 miles from the runway at the start of the descent. Pause the video and do you try number 3. An airline pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. What is the airplane's horizontal distance, d, from the raft? Since we know the length of the side opposite our 26-degree angle is 3 kilometers, and we're looking for the length of the side adjacent to our 26-degree angle, we're going to use the tangent ratio. Since the variable is in the denominator, the variable and the angle will switch places and will divide. Now use your calculator. 3 divided by 26 and hit the tangent key, then hit the equal button. So D equals approximately 6.150911525. So the airplane is approximately 6.2 kilometers from the life raft. Now is your chance to see how well you understand the lesson. Pause the video and do the lesson check. Don't forget to check your answers on the next slide. If you have any questions, be sure to ask me in class. Take another minute to reread the learning goal on the scale. Have you climbed any higher on the scale since we began the lesson?